Hey guys, in this tutorial we're going to take a look at building a Skywatcher Guardian from Legend of Zelda Breath of the Wild. So what that'll look like is a big hunk of metal floating around in the sky, shooting at anything that tries to go past it. So there are going to be a couple of prerequisites for this. The first one is it's going to be the Guardian video. I've made a previous video which is a couple of hours long. It was quite a long one where we built a Guardian laser just like in Breath of the Wild. Where the character walks past the Guardian rotates to look at the player, spawns like a sniper beam that locks onto the player, has a ticking countdown sound, and then launches a really fast projectile at the player. That's all set up in the Guardian video. I might put a link to that in the description, but you'll need that because we're going to be reusing the behavior tree tasks in the Guardian Skywatcher. Custom pawn sensing video, I'll put a link to that as well. You'll need to watch that one because normal pawn sensing isn't going to cut it for what we're doing today. We need to have our own custom pawn sensing because we're going to be manipulating the way that the pawn sensing faces and a few things like that. So you'll need to watch that video as well. The first video isn't compulsory. The first video is the first one in the series, in that we just set up, I ran over like basics of behavior trees and AI controllers and things like that, and we just set a few things up which we're going to be reusing today, but that one's probably not absolutely necessary because I'll explain the things that overlap as we go. So what this is going to look like is we're just going to set up, maybe I should just crack into it and we'll just go through it. Let's just do that. We'll just get started and I'll explain it as we go. So we're building a Guardian Skywatcher from Breath of the Wild, and it's going to fly around using physics and everything like that. Which means, actually, one of the other things in here is flying AI. You'll need to watch the flying AI video as well because we're using the same physics behaviors as in the flying AI tutorial. So those are the main ones: Guardian video, custom pawn sensing video, flying AI video, and maybe the first video in the series. And then you should be sweet. So let's just this is just an empty map basically, but let's just make a new map. We'll just start a new one. Start everything from scratch. Now I'm just gonna create a new folder in my content browser, which I'm just gonna call, I don't know, I'll call it Skywatcher, I guess. Skywatcher. We don't need anything in that yet except for the map, so let's just put the map in. So behavior tree, Skywatcher, and we'll just call this Skywatcher map. Okay, I'm just going to reset the Z to 0, make the ground a little bit bigger, and the first thing that we're going to do is we're going to chuck our old Guardian in from our previous video. So go to your Guardian folder and drop in your Guardian. We're going to be changing a few things for this dude. So go back to your Skywatcher folder. In here, let's create a new component, and this is going to be a scene component. A scene component is just an actor component with a transform. We need that transform. So this is going to be rotating scene component. I'm going to call it that. And what we're going to do is we're going to be using this component. We're going to be using a behavior tree task to call this component to rotate this component. To create a head turning thing on this guy rather than rotating the whole actor. This will make more sense as we go. So I might just open up my behavior tree for my Guardian. So open up your behavior tree for your Guardian, and what we've got in here is we have a rotate actor to search for player, BTT, and basically what that's doing is it's starting a timer which 50 times per second is updating the rotation to a new random look at rotation. So it's basically just looking around, but it's setting the whole rotation of the whole actor. And what we want to do is we want to create a new task that instead of rotating the entire actor, just rotates. So this is that Guardian, just rotates this component here, just the head. So just the head turns around. And that's going to be very important when we build the Skywatcher because we want the Skywatcher head to rotate around in circles, and we want the pawn sensing to update with it without rotating the whole actor around. Because that's how it works in the game, and it just makes a lot more sense, and it is quite easy to do. So I guess we could probably just start doing that now. We might even be able to just duplicate the code from this one and then just change it slightly. Oh, you know what? Maybe we could just add a new option here. So when we say to update rotation, so this is in your rotate actor to search for player behavior tree task. I'm just going to drag all of that out like that. I guess we could just create a new actor here, a new option here rather, to use a component rather than the actor. So we'll have a branch here, and we'll have a condition, and the condition will be rotate. What do we call it? We called it rotating scene component. Rotate. Actually, let's just call this rotate. Actually, yeah, we'll call it this rotate scene component question mark, and then we'll make that a public variable so we can edit that. Now, by default, we want that to be set to false because we want the whole actor to rotate. That's just how we built this. But say if we didn't want the whole actor to rotate, then we're going to need to do some stuff down here just to rotate the scene component. So this will require just a few things of setup. So once all of that's done there, let's grab, like once all of this stuff is run, let's grab our controlled pawn reference, and let's say get component by class. And what we're doing here is we're going to get a reference to the scene component, the rotating scene component on the Guardian. So I'll show you what I mean by that. So if we go here and we say rotating scene component, and then we put that on the base, and then attach the head to the rotating scene component like that. Now what happens is if we rotate this rotating scene component, only the head rotates. So the benefit of having that in a component is that you can have a rotating scene component here in the Guardian, you could have a rotating scene component in a completely different enemy with a completely different hierarchy here, and you could still use this behavior tree task to rotate that component without needing to like change the logic. So now in the component class we're going to type in rotating scene component. Hopefully today doesn't take too long. I want this to be a sort of quick video. The last couple of videos have been really long, and it's draining me, man. But that's okay, because it is fun. So let's just type in is valid off here. I got a feeling it's going to be a long one today, but look, to be honest, that's fine. I'm just going to close that tab up there, whatever the hell that was. So we're just checking if the actor or the control pawn has a rotating scene component. If it doesn't have a rotating scene component, let's type in print string, and actor doesn't have rotating scene component, just so we know. If it's not working, we get an error message that says why. If it is valid, let's promote that to a variable, and this can be called rotating scene component reference. And then off of valid, we set that there like that. Now that should be all we need to do there, so we can just plug that into begin rotating, and then that can just be part of the setup, just like that. Now, if we're doing rotate scene component, so if that's set to false, you know what, actually, I'm just going to put a little knot here. So if rotate scene component is set to false, not makes it true, and true means we'll rotate the entire actor. If the other case is the case, then we're going to have a reroute node down here, and we're just going to rotate the component. So basically that's going to be the exact same thing, except instead of setting actor rotation, we're just going to set world rotation of our rotating scene component reference. So we can put that in there like that, and then this here will be exactly the same, I believe. So what I might do is I might collapse that to a function and just call that get new rotation, and we can make that pure, and then if we click in there to make sure it's all looking good, that looks pretty good to me. That can just sit there like that, and then if I go Control C and V, we can just plonk that down there as well, and drag those across, tidy it up a little bit, and then we want to just go up there like that. Now, is that everything that we need to change? So over here, check if has finished rotating. So what we might do is we might just disconnect that there. This here uses the controlled pawn and gets the actor rotation to check. Let's promote this to a variable here and call this rotation tolerance, just because we might change that. We might be able to change that later, but for now we could probably even just leave that as not public. Like that's fine. And I might just copy all of this and just put this down here like this, or maybe we could even, no, that's fine, let's just do it like that. So let's just put this in here, plug that in, except for this one here, instead of getting the actor rotation, I just thought of a better way to do this, and I'm going to do the better way. So this is all good, except this part here we just want to have a select. We just want to have a select node. God, this is getting a little bit tangly, but that's fine. So we're going to have rotate scene component into there. Now if we're rotating the scene component, or if we're not rotating the scene component, we're going to get the actor rotation. If we are rotating the scene component, true, then we're going to get the rotation of our thing here. So we're going to say get world rotation. And that's going to go into there, and now this needs to connect back up to here, like that. So now this check will work regardless of what we've got set here. It would be cool to do this on like a live stream maybe one day, so I can like answer questions as we go, because I'm not always 100% sure if what I'm doing is making sense. So maybe I'll look into that in the future, but for now I guess this just has to do. And if you have any questions, leave them in the comments, but just I guess do your best to just follow along with what I'm doing, and hopefully I'm not making it sound too confusing. So if I were to just run through that, I'll just run through this bit again. This selector node is just going to toggle which rotation it takes in to check if it's equal, depending on what you have set here. Now, that should be all good. So let's just check that that's set to false as the default. So now if we jump into here, he should still work like normal. So let's just see. He's rotating his entire actor around just like that. That's because we had the use component set to false, and now he's seen us and is attacking us and all that. But if we were to go to the behavior tree and set rotate scene component to true, and nothing's happening. I wonder why. Let's see. I wonder why nothing was happening. That's weird. Let's have a look at his behavior tree. Okay, so he's doing something. I'll just pause it and I'll have a look. Okay, that was quick. I found what it was. So if you go into your rotate actor to search for player BTT and your new rotation function that we made here, the new rotation that we need to set him to, it's not lerping between the current location here, is we need to have another selector node here like this, because if we're using a component, we're not using the current actor location. So that the return value goes into there. We have our rotate scene component plugged into the index there. If we're not rotating using the scene component, use the actor rotation. If we are rotating using the scene component, we get the world rotation of the scene component, and then that goes into true like that. I mean, I'm pretty sure that was what was wrong anyway, so let's just go in and see. Okay, cool. Look at that. Now what you'll notice is that he isn't seeing us even though he's looking directly at us, and that's because his pawn sensing isn't updating along with his eye. If I walk in front of him over here, it'll activate, and that's because his pawn sensing is stuck facing that one way. And this is why we need the custom pawn sensing, because if we're rotating just a component like a head, we need the pawn sensing to update with it. So I guess now that we've got that done, the head is rotating fine. Let's just change that also for the yaw to face target. So when he's chasing the player or he's seen the player, his whole rotation updates to face the player. We want to just have his head rotate here as well, because the Decayed Guardian sits in the ground and the component on the top is what rotates around. So here in our update rotation timer, we have some bloody complicated looking spaghetti here. I'm just going to copy that controlled pawn thing and just put that over there to make that a little bit less cluttered. And maybe just give me a sec while I figure out what the hell is going on here. So we're finding the lookout rotation from us to face the target. That's all fine. We can use the controlled pawn reference for that. Maybe we should just copy this whole thing and just have a branch. So let's just have a branch here. and we'll do the same thing as last time. We'll just say using rotating scene component question mark, and that needs to be public so we can toggle that in the behavior tree. If we're not using it, then go ahead and set the actor rotation as normal. If we are using it, let me just move this abort. I might move the abort up here actually, and I can drag this comment window down so we've got a little bit of space to play around. Now if we are using the rotating scene component, which by the way should be set to default as false, let's just add a reroute node down here. And we're going to grab in we need to get our component reference. So if we go to the receive execute over here, we need to get our control. Actually, you know what, let's just copy this from last time. So if we go into our rotate actor to face blah 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 blah, this whole section here, let's just copy that minus the comment window. You just control click to deselect. And now if I go into here, let's just get rid of that receive execute window for a sec. Let's put that there like that, plug that in, and now just promote this to a variable or create variable, rotating scene component reference, compile and save. Controlled pawn, that just needs to be the controlled pawn ref. I named that differently here. So that should be all good, just like that. And now I can just move that down, and then this can be comment setup. And then this here is begin rotating. Okay, so now we have a reference to the rotating scene component. So now down here, where is it? In there. So now what we want to do is we want to set the world rotation. Set the world rotation of the rotating scene component. Now all of this here should basically be the same, honestly. So let's just plug that in and let's just see what's going on. I'm just going to pause for a sec. My brain's getting a little bit sore. I'm a little bit slow this morning. Okay, so if I were to just copy this controlled pawn reference thing here and just plug that into that bit there, what is basically going on here is this whole section here. This whole section here is just getting the look at rotation to face the player, and we're setting that as alpha B. As the lerp for B. And then the output of this is just interpolating between A, which is our current rotation, and B, which is the desired rotation. So what we might do for here is, instead of getting the location of the controlled pawn as the start, let's grab our scene reference and we'll say get world location, and we'll use the location of the scene as the start point to find the look at rotation from. And then we're going to be lerping between not the controlled pawn's rotation, but the rotation of the scene. So we'll say get world's rotation, and then that's going to be, we're going to be interpolating. So this is basically just interpolating between the rotation of where we currently are and the rotation that we want to look at, which is the direction of the player, which is the target actor reference. Now we could just plug that straight into there, but then what's going to happen is we're going to get like pitching and rolling and things like that as well. So what we had going on up here is we had this brake rotator, which I'll just build this and I'll show you what's going on. So if we grab in this again, rotating scene component reference, and we get the rotation of that, and then we break it, or to be honest I could just split this pin there, so we break it. What we could do is we could keep the roll and the pitch the same while taking the Z from this value here and getting the yaw that's required to look at the player. Hopefully that makes sense. So if we say make rotator, well, you know what we could probably do? Let's have a select node down here, and the select node will have a new boolean, and this could be called allow, or this could be yaw only question mark. And you know what, we might only make that just work for the component. So I'll say yaw only for component only. And then I'm going to plug that into there like that. Now, default, that can be set to true because we only want the Guardian that we've got right now to only yaw around and not be able to pitch. So if yaw only is set to true, then we're going to be making a rotator from the Z, which is the yaw required to look at the target, but we're going to be keeping our current roll and our current pitch. Okay? I'm saying okay like it's a question, as if you can answer me and like follow along, but that's not the case right now. So hopefully that makes sense. Now, if we want to allow the pitch and everything, then we could say make rotator, and instead of taking the roll and pitch from the current, we can take everything from the look at rotation, like that. So that is a little bit clumsy and a little bit messy, but well, it's not clumsy, it's just messy. Like that'll work like a dream. So yaw only is set to true by default. Using the rotating scene component is set to false by default. So let's just leave that as false for now, and let's see what happens. So he's rotating his head because we set that up in the previous thing, but he can't see us because the pawn sensing isn't updating. Now if I walk in front of where his pawn sensing is, he'll start rotating his whole body to look at me. See how his body's rotating? Now if we go into this Guardian thing here, the Guardian behavior tree, and we go to yaw to face target parallel, and we click use rotating scene component, now his head should rotate to face us. Yeah, there we go, that's much better. But his pawn sensing will still stop, I think, if I walk over here. Yeah, because the pawn sensing isn't moving with the head, but the head is following us, which is beautiful. And another thing that you might notice is when we jump up and down, his head doesn't pitch. If we were to tick yaw only to false, his head should now pitch when we move up and down. See that? So we're going to be using that for the Skywatcher, because the Skywatcher has a pitching movement with his head as well as a yawing movement, I'm pretty sure anyway, whereas this one just rolls, it just yaws around in a circle. So that's our Guardian all set up, I believe. So I'm just going to set yaw only to true again for him, and he should be basically done, except for the pawn sensing. Actually, let's just go ahead and give him the custom pawn sensing. So if we go in here, custom pawn sensing component, compile, save, attach that to the eye, and the forward vector of that is facing X, which is what we want. That's the way that the eye is facing. And to be honest, actually, maybe I might just sit that right on his eye like that. So I've just reset the location up there, reset the scale as well. The scale doesn't really affect anything. And here are his pawn sensing parameters that we've set up in the previous video. I might just put that debug on for now so we can see where he's looking and what's going on. And I'm pretty sure that's all we needed to change for him. I'm pretty sure now that that's added, he'll automatically use that. So let's just go ahead and see. Okay, so that's his pawn sensing. That cone looking thing. That's working like a dream by the look of it. It is a bit choppy, like it's got a very low tick interval, so I could probably run out of it. No, maybe not. Cool. But it's ticking every 0.5 seconds or something, and it's rotating with his head, which is exactly what we want. So that's done. The Guardian's done. So I can close the rotating scene component. I can close the Guardian after I no, I can close the Guardian behavior tree. This rotating actor task I can close. The Guardian BP, I'm just going to untick debug because we don't want that ugly debug cone appearing when he's pawn sensing. We can close him, and we can close the autoface parallel. So that was the Guardian done, and that took a little bit longer than I thought, but that's fine. Now let's build the Skywatcher, which is basically a Guardian that flies around. So delete your Guardian. The reason that I wanted to set up that Guardian properly was just to demonstrate how the custom pawn sensing and the rotating scene component work together, because that's going to be absolutely like essential for the Skywatcher. And now I don't think we need any new code for the Skywatcher, honestly. That was the only new code that we needed, so the Skywatcher should be straightforward. I covered the prerequisites of what we needed to see. I think we've built the components for the Guardian now, so we can do all that. Integrate custom pawn sensing into Guardian, that was easy. And now let's build the Skywatcher setup. The Skywatcher setup. We'll put in our component for the rotating head, which is the scene component, the rotating scene component, and the pawn sensing. Okay, let's do that. So behavior tree, Skywatcher, new blueprint class. It needs to be of type character. I covered this in the flying AI video. All your flying AI needs to be of character type, just so we have access to the Capsule Collision, because that's what we use to add the physics to. So this is going to be Skywatcher BP. I'm going to drag that tab and just dock it into the engine up there like that. Let's grab a static mesh. Let's just keep this guy really ugly and hideous and basic. We'll grab a chamfer cube. I don't know, what size should he be? Maybe like 3 or something. And maybe a little bit thinner this way. Alright, so we'll have that. Let's have a another static mesh, which could be a cylinder, which is going to be his neck sort of thing. This is going to look nothing like a legit Guardian, by the way, but it doesn't really matter. Not for the purpose of this video anyway. So that's going to be his neck sticking out like that. And then I'm just going to give him one more static mesh, which is going to be his head. Oh, we might need another one actually. Well, let's just see. Let's just see as we go. I mean, you could use this in your game, to be honest, like just depending on like the kind of feel that you're going for. Me personally, I like this really fucking like goofy, unnatural looking enemies. Like it obviously looks cool if you have the knowledge or like the friends to be able to build like really cool looking models for your enemies, but like to be honest, like there's something horrifying about shit that is like really low poly and like just kind of thrown together and looks like a monstrosity, like a Frankenstein enemy. Especially if the AI is really good, like it just makes it so terrifying. Like scary AI and really hideous, unnatural looking meshes. Now I should probably be naming these. I'm just going to add another one called Eye. And this is going to be another material sphere. And where the hell is that gone? Is that just here? Okay, and that's the same size, so we want that to be a bit smaller. So drag that white square in the middle. This is just so we can see which way that he's facing. So that's his eye. And I think we could give him a cool material. I think we set some shit up for the Guardian actually to make his eye change colour, which we might do. And I mean, you could give him like jets on the sides or like fans on the top or something if you wanted, but whatever, this will do for now. Okay, so we need to have the hierarchy here proper. So this one here is going to be the head, and the head is going to be parented to the neck, and the neck is attached to the body. Okay, and that is absolutely disgusting. Now let's grab this capsule component and hold Alt and then press right click in your window, Alt and then H. And now what we need to do is grab that body and just drag that up so that the center is roughly where that capsule collision is. And then just resize this capsule so that it kind of fits the box. It doesn't really matter, but like, you know what, I might just have it like this. Just so that it fits the eye. I mean, this really doesn't matter. And then you hit Alt-G to go back to normal. Okay, and that's going to be our terrifying Guardian. Now, let's open up our old Guardian BP, just to see how I set that up. So we had a dynamic eye thing set up in the construction script, so I might just copy that and then put that in the construction script of this as well. Oh, and look at that, the eye primitive component is named the same. We've had an eye in here and an eye in here, so that works well. You want to create a new variable for the dynamic eye material, and then what's this, generic emissive color changing component. I think that's a component that we added in there. So if we type in generic emissive color changing component, compile and save, that'll have a reference to that. This doesn't need to be public or anything, that's just used within the behavior tree. And if we go back here, now his eye's blue. That's because of the logic that we set up in here, I think, inside of the component. I'm not sure. Oh, it's because that's the color of the material that it's now been set to. And now we have a behavior tree task to change the color of his eye whenever he sees the player, but that's not important. You don't need to have that if you didn't set that up or whatever. So let's go ahead and give this guy the physics component that we built in the last tutorial. So what was it called? Physics move to parameters. So compile and save. I think we need to set that up. I'm not entirely sure. So let's go back to our flying AI. And let's just have a look at how we did that. Nothing in the construction script, and just the AI controller. So we're going to need to set up an AI controller. So let's copy that and put that into the begin play of the Skywatcher. So all this is doing is just getting the AI controller, which we need to set. So go to Skywatcher BP self, go down to AI controller class and tick my AIC. We set up my AIC in the first video in this tutorial series. So if you want to set up your own AI controller, go ahead and watch that. But it's pretty empty, to be honest. Like basically all it does is runs this setup event, which basically just runs this whatever behavior tree you've given it. So if I compile and save and make that a variable and make that, it doesn't need to be public, and we give him a behavior tree, all it does when you set up the AI controller is it saves a reference to the behavior tree, saves a reference to the pawn sensing target, which is the player pawn. It runs the behavior tree that you've set it, and then all it does is just set the Blackboard key on the behavior tree. It sets a Blackboard key for a target, it sets a Blackboard key for an origin, and then it just sets up the custom pawn sensing that we have in the that we did in the custom pawn sensing video, and it's got a default pawn sensing down there as well. So all that's covered. This pawn sensing is covered in the first video. The custom pawn sensing is covered in the pawn sensing video if you're interested. So that's all the AI controller does. Is it just basically runs a Blackboard at the moment. So let's give him a Blackboard. We'll go not a Blackboard, a behavior tree. So if we go into Skywatcher and we go artificial intelligence and then behavior tree. This can be called Skywatcher BT, and let's give him a Blackboard, which will be the AI Blackboard, which is the same for everything, everything that we've been using. And we'll have a selector which runs behaviors from left to right until one succeeds. Lowest priority on the right can just be a wait for now, and we can just have him constantly waiting forever. We can close the AI controller. We could probably close the flying AI right now. The Guardian BP we can close, and we just need the Skywatcher and the Skywatcher behavior tree. And we need to give him his behavior tree, which is the Skywatcher BT. So now what would happen is, now that he has his physics move to parameters, which I might actually just show you really quick. So in the flying AI video, we don't need the flying AI, we need the physics move to parameters. So whenever this begins play, it just saves a bunch of shit like references to the owning character and the physics capsule. It sets the capsule collision to simulate physics, so it's going to set this to simulate physics. It's going to also disable gravity. It's going to set the gravity scale for the character movement to 0, and then it's going to set whatever linear damping and angular damping we've prescribed it. So if we look into our Skywatcher thing here and we click on our physics move to parameters, all of our variables are down here. It's automatically going to set its physics and everything like that to work. So if we start the game right now, we should be flying, and then we can just toggle how fast we want him to move linearly, how much we want him to rotate if he hits something like angularly, how much we want him to accelerate with the behavior tree tasks, and etc, etc. So if we go into our behavior tree Skywatcher and then grab our Skywatcher and put him in the world like that, which he looks like a good size actually, that looks pretty good. I'm just going to save everything by hitting Control Shift and then S, and then if I hit play, he just fell straight down, and I wonder why that would be. Does he have his physics move to parameters? He does. He has his capsule component. I must have forgotten something in the setup. So, let me just go back to flying AI, and if I go into our physics move to parameters, this happens. Oh, setup. We didn't call the setup event, so this doesn't happen on begin play, this happens on setup. So what we need to do is go into, I wonder if we can do it on, it'll need to be on begin play because we're using object references, I think, here. Well, I'm not entirely sure. Let's try it in the, well, let's see what I did for the flying AI. Sorry if this doesn't make any sense, I'm just talking to myself. Where the hell is the setup event for this guy? It's never been called at all. Huh. Weird. Oh well. That's really strange. So let's just grab the physics move to parameters in the construction script. and let's just say setup. And now he should fly, I believe. He should hover at least. Okay, he's hovering now because we've set him up properly. I'm just going to pause for a second and figure out why the flying AI in the previous video is working when I haven't set it up. So in the previous video, the flying AI video, the reason that he was flying without the setup event was because I manually made him simulate physics, and I manually disabled his gravity and everything like that. But his movement parameters here, these were also still working because they're not they don't require the setup event in order to be called from the behavior tree to change the way that he moves. So everything in this guy just happened to be working like normally, even though I forgot the setup event. So if you're using the physics move to parameters component that we set up in the last video, make sure you call the setup event in the construction script so that it sets everything. I guess I'm just going to comment that and say setup physics movement. Okay, now he's ready to go, so we can probably start building him now. So lowest priority behavior apart from the weight will have a sequence, and this can be called patrolling sequence, like that. So all this is going to be a sequence runs from left to right, all of the things in a sequence, all the tasks in a sequence. We had a task for patrol what was it called? If we go back into our flying AI behavior tree, we used it here. Find a valid flying location and then add force to location for flying AI. So find valid flying location and then add force to location for flying AI, and then we might have a wait node as well, so once we get there he can wait for a little bit before moving to the next point. Now the wait, we can have that to be 2 plus or minus 1 seconds, just so it's a short wait. Now the flying location, we have a couple of different options here for how we want to do this. The min distance and the max distance, that's if you're roaming randomly, and we don't want to use that for a Skywatcher. I want the Skywatcher to patrol a path. So let's have the debug type on for now, just so we can figure out to see if he's working correctly. Now the output key is the move to location, because that's what's used here to determine where we're going to move. So output key is move to location. Actor to get location near, that is irrelevant if we're using the patrol points rather than actor key. So if we tick that to true, this is going to use the patrol points blueprints that we place into the world to get a random location to move to. So in our flying AI video, we set up patrol points like this. So I'm just going to put one there, and maybe a third like over here, and he'll just patrol back and forwards between those when we set this up properly. If we wanted to, we could make these a little bit higher. He uses where the billboard, the little lizard, that's the height that he travels to. So let's just put them up a little bit like that. Now, so that's all set up. Sorry, I'm in the wrong one. That's the flying AI behavior tree. We want to go to the Skywatcher one. That's all set up. That's getting the location. Now this is moving to the location. The move to location key, that is set from here, so that's good. That's what we want. Max time allowed until auto fail, 10 seconds fine. Display debugging, let's set that to true for now. Update rotation to face direction. We want him to face the way that he's going for now, so that's good. And we'll have that true, and we can save that, and that should be all good. Shortest path just determines the way he rotates if he's updating his rotation. If you have that unticked, he might turn like back and forwards and look really wigged out, so let's just see. There we go, so he's flying towards his spot. He's flying towards another spot, and his rotation is a bit off. See that? He's facing on a 90-degree angle to the way that he's going. So if we go back into his blueprint, oh, what's this? So something, that little error, what that was about was when he was getting his valid flying location, there's this actor to get location key near that was set to a vector rather than an actor, and that just caused this to return something invalid, even though it wasn't being used. So I wonder if I can... You could probably build in a little failsafe here to stop that error from coming up, but I can't be bothered doing that right now because it's not really relevant to the tutorial. So this actor key, I'm just going to set that to target, even though it's not being used, just to make sure the error doesn't come up. Now, that max V message, I'm just going to probably go and disable that as well, to be honest, because that's kind of annoying. Actually, no, that's not annoying, because I set this to display debugging, which we don't need anymore. And now it should go away. Yeah, it's gone away. Okay. And I just fell off the edge of the world, flat Earth. Now, if I go to Skywatcher BP and we look in here, the reason that he was facing all fucked up is because the X vector is this way and his body's facing the wrong way. So grab his body, hit E to rotate, and then just rotate him to face the correct way. Okay, and now if we hit play, now he'll face the way that he needs to be going. And he's got a nice slow velocity, but we can crank that up. Change his max velocity to, I don't know, 1000, like that, and maybe the tolerance can be a little bit bigger. The tolerance can be like 150, so he'll stop moving once he's within 150 units of the target point. So there we go, now he's moving a bit quicker. And he has quite a strong linear damping by the look of it, because he's slowing down really quickly. So what we could do is we could reduce that to maybe like 4. It took him a while to get to the point, as you might have seen. Oops, and I just fell off the world again. Come on. Okay. There we go, so now he's getting there a bit quicker. That looks really good, actually. And if you wanted him to like fly around really smoothly like the ones in Breath of the Wild, maybe what we could do is we could set that to like 1. Set the tolerance here to like 300. The acceleration looks pretty good. Let's just see how that looks actually. He might look really smooth now. Maybe we could reduce the acceleration just a little bit because it looks a little bit unnatural. So we could change that to maybe like 2000. But what was it previously? Was it 500? No, it was 5000. 2000. So we'll reduce that, and maybe what we could also do is we could reduce this weight. So that could be 1 plus or minus, I don't know, 0.5. That still looks a little bit quick, but like you can play with this and you can make it however you want. I might just make that 500. Really reduce the acceleration, and let's see how that looks. That might be a little bit too slow, but you know, like whatever you want. The point is that it's working. It's working really well. And just because I can't help myself, I'm just going to put that back to 2000 because I liked how it was at 2000. Now, so this is his patrolling sequence all set up. You can comment this if you want, by the way. If you highlight everything and then say correct comment. This could be called patrol and look for player. Okay, so this is assuming that he can't see the player. Now, the next priority up is we'll have a sequence here, and this will be attacking sequence. So this is if we can see the player. This is what we're going to be doing. Now, the first thing that we want to do is I might just open up my Guardian behavior tree, because we had some things in that we want to reuse, like this thing here. We basically just want to do the same thing. This is the cool thing about all the tasks that we've built so far, by the way, is you can literally just copy this and then just dump that in here and it'll basically work. Like you might need to change a few things around, but like all of these tasks are reusable across different actors. So as long as you've got like universal components like the rotating scene component and like the Guardian Blast component and everything that contains all the information that you need, like for the Guardian Blast, for example, in this setup here, Guardian Blast component, as long as you've got that and like all the information in that's contained, like you can basically just reuse this for whatever you want. So I might even just go ahead and just copy that whole thing just there and then just dump that in here like that. And I'm just going to I might even get rid of that attacking sequence and just put that up in there like that. Now, am I recording? Yes, I am, and I've been going for 10 minutes. Okay. I think that's probably like an hour all up. I don't know, 40 minutes all up maybe. So, this is the attacking player sequence, or what do you call it, tree. If can see player is set, we'll attack. If the result changes and we suddenly can't see the player, then this aborts. Or if we can't see the player and we're running this, and then we can see the player, this will abort that. So this will take priority over this tree over here. The first thing that we're doing is we're going to be changing the color of the material on the eye. So that was this whole thing that we set up here, this generic emissive changing color component, whatever. This bit here. This is a parallel node that while this is running, the eye will be red. And so when this aborts, it'll go back to active color. We could even change it if we wanted. Let's change it to, like, I don't know, green, just for, I don't know, just for a laugh. And then when this is no longer running, it'll turn back to blue, the default. Now, while the eye has changed color, it's also going to have another parallel, which is yawing to face the target for parallel. Now, the target key is the player. The alpha is 0.5, so it snaps quite quickly to the player. If that was 1, it'd be instant. If it was like 0.1, it'd be quite slow. 0.5 is like pretty quick. Using a rotating scene component, do we have a rotating scene component? We do not have that in here yet, so we need to add in our rotating scene component. Go to your viewport, put that, well, which bit do we want to rotate? Probably the head, right? So attach the head to that. You want to attach the rotating scene component to the neck, and then attach the head to the rotating scene component, because the rotating scene component is what we're going to be rotating. If I had $1 for every time I said a rotating scene component in this tutorial, I would be a rich man. Okay, so where the hell are we? Do we have a rotating scene component? Yes, we do. Do we want to yaw only? No, we want to be able to pitch as well, and we want to be able to pitch and look at the player. Let's add in custom pawn sensing as well, because we haven't put that yet. So let's add in our custom pawn sensing component, and we can attach that to the rotating scene component. And let's just have a look at that pivot for the rotating scene component as well. We don't want it to pivot around there. That's an ugly spot. We want it to pivot around. Oh, we don't want it to pivot around there either. Why is that? Is that because it's attached to the neck? Yeah, it's attached to the neck. So I wonder if I can just move that down to like there. Or maybe a better way to do this would be to grab the head, reset that to 0, and then grab the rotating scene component and then drag that down to where it looks natural. So what's going on now is the head is right in the center of the rotating scene component, so whichever way this rotates, the head will be rotating right at the center of the sphere. And of course the eye is going to come with it, and so will the pawn sensing. The pawn sensing I might just attach to the eye actually, and I'm going to set its location to 0, so it's right on the eye like that. The rotation is fine, it's coming out of the eye in the X direction, which is good. The scale doesn't really matter. Okay, so now he should have his custom pawn sensing working as well. Because of the way we set that up in the custom pawn sensing video, it should just automatically work, and it'll update the Blackboard automatically, which is fantastic, because now this will be working automatically. Now, by the way, if I'm using a lot of components and like code and like even just words that isn't making sense to you like at all, it might pay to just go back and just rewatch the earlier videos if you're interested in learning more about this behavior tree stuff. It is difficult to do behavior tree tutorials without doing a lot of setup, because like what I found is just behavior trees in general, they're sort of a thing where they're slow to get started, but once you've sort of built up all the logic and like foundational code and components and tasks that you need, like it can fuel, like it just accelerates, and you can do like crazy combinations of different tasks for different AI, and you can just rapidly create all kinds of new combinations and new AI really quickly, but it just takes a while to get started. So for tutorials, it's difficult to just like go in and do like a 10-minute video that just explains anything important, because you spend most of that time setting up and doing like good practices. So if you are interested in learning like how to do behavior trees and to learn how to do better AI, and you enjoy my style of teaching, which I can't guarantee that you do, but if you enjoy my style of teaching and the stuff that I'm covering, and you want to get good at it and you want to learn more, then like it would pay to go back and go from the start. I'm not saying that just to get views, like I'm not really too concerned with how many views these videos get, but just for your own understanding, because it's just I like to do them this way, where I can build up a lot of code and then constantly build on top of it and teach like the best practices and things. But that's enough rambling for me. I'm just gonna get back to the tutorial now before I get too far off course. So yaw only, we want that set to false because we want the eye to be able to pitch, and it'll pitch properly now because the head rather, is set right at the center of the scene component there. Now, while he's looking at the player, we're going to have another sequence here, and this sequence is charging a Guardian Blast. So we can set that up. The target key is the player. The countdown is 5 seconds. The projectile class is whatever that is. The projectile velocity is that, and the debug type is none. That's good. And if I look at this, the finish mode is immediate. So whenever this finishes, this stops running, and this whole part here is marked as a success, and then it'll move on to the next thing in the sequence. So this, I just designed this to run in parallel, because while you're charging the Guardian Blast, you could have some logic to get him to chase the player, for example, which maybe we might set up right now. Oops, actually, you know what? Maybe we should just check. That's the Guardian. We want this here, so let's just have our wait node back in here. Let's just check that this works as it is, and let's just check that he rotates his head and everything. And then what we'll do is we'll build the chasing player thing down there. So let's just, I might just put in like a wall so we can hide behind something and just observe his behavior. So where's his, that's the patrol point. So I'm just going to spawn in over here. Where the fuck did he go? That was weird. What happened to him? Huh. God, I wonder what the hell just happened then. It could be because these parts are now rotating and shit and it's touching his collision, so maybe what I might do is I might grab this body thing and I might just, let's just turn all the collision off for now. So we'll go overlap all, overlap all. This could be wrong, by the way, I'm not entirely sure, but let's see. Overlap all and overlap all. This is just the first thing that I check. So now none of these static meshes have any collision. And he's working normally again. Fantastic. Okay, and he's flying around looking pretty good. And if I go back in here, and can he see us? Let's try and get him to see us. Okay, his eye's gone red. Oh, green rather. And if we move around, he's looking at us. And I don't think he's shooting because he doesn't have a Guardian Blast component. And see how his eye is only rotating, or his head, and the box isn't. And if we walk underneath him, his eye is pitching as well. Fuck, that is actually so cool. And if I were to lose his sight, which I just did because I ran out of his range was only 2000, he goes back to patrolling. And he looks all fucked up. And the reason that he probably looks all fucked up, well, I'd say that his body's facing the correct direction, but now his eye has a funny relative rotation, so it hasn't reset to face forwards. So maybe what we could do is in this yaw to face target thing, when this receives an abort, maybe we could set him back to his original rotation. Do we have an original rotation on our Blackboard? No, we just have an origin. So what I might do is I might just add a new key called, oh, this might be actually a little bit tricky. So maybe what we'll do actually is if we go into our yaw behavior thing, so this is the thing that updates the rotation of the head. When we receive the start, the execute, let's just save the original rotation of the component. So if we're using, let's just put all of this over here actually. So we'll have it all in order. Now, if we're using a rotating scene component, or rather, maybe even, hang on. I just realized if this doesn't have a rotating scene, oh, hang on. Well, how did I have that set up? If this doesn't have a rotating scene component, we just want that to skip this here, but we want it to continue the logic. Because we want this to run even when things don't have a rotating scene component. We want this to be optional. And I've got a feeling we might have set that up for something else as well. If I go into my Guardian behavior tree, this rotate to search for player, this rotating scene component thing, that needs to connect back up to there, because this is valid node. We don't need that to terminate the task. We just need that to check whether or not there's a component here to set as a reference, if we're using that later, which we might not even be using it. So if we wanted to, actually, we could even delete that and just use this is valid node to check if it has a rotating scene component, and then that can be the criteria for whether to rotate the actor or rotate the component. We don't actually need that boolean, but it's set up now and I don't want to change it, so because it works, so we might as well just leave it and get on with something that's a bit more important. Okay, so this yaw to face the target task, what was I going to do? We need to save the original rotation that the component was facing so that we can restore it to the original rotation when this receives its abort, so that when he's flying around his eye isn't facing off in a fucked up direction. So if we're using our rotating scene component, actually, you know what I might do is if this is valid, so this is what I was talking about before, how we could use this as the criteria. If this is valid, then what we're going to do is we're going to get this rotating scene component, which is under components up there, and we'll say get worlds, or should we say get relative rotation? We'll say get relative rotation. Get relative rotation. No, it's not set relative rotation. Fuck me. Get relative rotation. And we'll promote that to a variable and call this original component relative rot. And just set that there like that. So if we're using the scene component, we want to save the original relative rotation when this starts. Now, then it'll start rotating and doing all shit fucked up, and it'll making the rotation all funny, but we'll still have the original saved there. So now what we can do is when we do the abort, in other words, when we stop the rotating thing down there. We just want to set it back to the origin. So we grab our rotating scene component thing and we say set relative rotation, and we set it to the original relative rotation. So now his head should turn back the way that it began. Okay, let's test that works. So he's flying around. Let's just turn off that debugging box because we know that that's working. So that would be find valid location, I think. Debug type, reset to none. Okay, so he's flying, and then when he sees us, he's not shooting because he doesn't have a Guardian Blast component, but his eye's updating, and then if we move out of range, his eye resets to 0. See that? So now when he keeps moving, he's facing forwards again. Fantastic. So that's all good. This one's done. We can close that down. We can close our Guardian behavior tree. We can close our Flying AI behavior tree. We're getting close to the end now. Now we just need to set up the Guardian Blast. If you pay attention at the start, it didn't give us a message that it didn't have a component. Oh wait, hang on. So when he sees us, have a look up in the top left. I think we'll get a print string. Task needs but doesn't have component, and it didn't give us a name of a component. That's awkward. Where's our Guardian Blast? Guardian Blast info component. Guardian Charge and Blast. Let's open that up. Task needs but doesn't have a component. I tried to get the display name of a component that doesn't actually exist. That's awkward. So let's just delete that. BTT Guardian Blast doesn't have Guardian Blasting. I should probably give it the proper name. Guardian Blast info component. So that message would have popped up in the top left of the screen when he went to shoot, but he couldn't shoot because he doesn't have the component. So we can close that down and go to the Skywatcher BP, add component, Guardian Blast info component. Now the location of this is where the Guardian beam starts, so let's attach that to the eye and then reset the location to 0 and the scale to 0, I guess. And now are there any parameters for that? It doesn't look like it. Maybe there's a setup event for that though, so let's go into our Guardian BP and let's just check. So if we go to construction script, nothing, event, nope, nothing. Okay, so I guess everything is contained within the task here. So we have a countdown, we have a projectile velocity, a target, and everything like that. So if we play now, and when he sees us, now he's targeting us. And he should shoot. Yeah, boom. Bang. And if I were to move out of range, he'd abort it and he goes back to normal. So that's a fully functional Skywatcher. And if I go back in range and he sees us, he's targeting us again. Now the only other thing that we need to do, well, we don't need to, but let's just do it anyway. I'm pretty sure when the Skywatchers in Breath of the Wild see you, they just stop what they're doing and they drop down their head thing and they start shooting at you, but they don't continue to move. But let's just make ours continue to move just because. And to do that, we set up some logic in a previous video, I think, actually. So let's go to Flying AI and go to the Flying AI behavior tree. This is all we need, actually, so let's just copy that. Let's copy that, save this, close that, and then just paste that here. So while we're shooting at the player, we're going to have a sequence running, and that sequence is going to find a valid flying location, acted to get location nearest the target, and we're going to be going 300 units above the target. So that's the location that we're going to be moving to, or we're going to try to move to. And it'll have this deviation from that point. So it'll get the target location, and then it'll add to that some value. It'll add a vector in a random direction of length between 500 and 1000. So it'll just constantly move around your head while it's charging this thing. And then we have the add force to the location. So we got the location that we want to move to from this one. And now here we move to that location. We give 10 seconds until we pick a new location and start again. Do we want to update our rotation to face the direction that we're going? No, we don't, because we're updating the rotation that the eye is facing with this. So that needs to be false. Shortest path doesn't matter because we're not using that, and we have a debugging option there if we need it. So let's see what happens now. So he's flying. Come on, see me, you dickhead. There we go, look at that. Now 300 might be a little bit too low, but that's looking brilliant. So let's go into this location thing, and let's just go maybe 600. So he'll hover 600 units above our head. Alright, where are you? Come on. Wait. There we go. Look at that. Holy shit. And he hit us with that projectile like instantly. He's really fast. I don't know if you can hear that ticking. Yeah, just like that. And now he's lost sight of us because we're out of range, but we can change that range. So if you go into Skywatcher BP, custom pawn sensing, 5,000. That's a bit better. And maybe we could change his interval to 0.2 so he sees us. He ticks a bit faster to see if you can see us. Alright, where are you? Come on. Oi. Oi. There we go. Now he's a bit harder to lose. His range is a bit longer, and that was a fast projectile. See, he can still see us. And now he's lost us. Oh, and he's seen us again. Cool. That's it, honestly. I mean, you could add some particle systems on him, and you could put in some better models than this, but you need that hierarchy. I mean, I don't need to explain everything that we've done. If you followed along, it'll make sense. You can comment this out now if you want. Create comment from section, and just call that chase player tree. And I'll close those down and let's just see if that's everything that we needed to cover. Build the Skywatcher and the rotating head and the pawn sensing, patrolling behavior, chase player behavior, that's everything. Alright guys, that's it. That's the end of the video. If you have any questions about this, let me know. If you have any other requests, particularly anything from Breath of the Wild, honestly, because I fucking love that game. I've got tutorials for like the runes and things like that, if you're interested in those. Well, some tutorials anyway. I have got a project download that you can have a look at if you want, where it's got all the runes and that set up in it, so if you wanted to mine through that logic, you can download that project and have a look. Let me just put a little note here so that I remember to put a link to that runes video in description, and I'll put in links to the previous videos that you might need to watch if you wanted to follow along with this one. But that's it. That's a Guardian AI tutorial done. I mean, this is pretty gangster, honestly. Like, oh, and now he's fucked up because he hit his head on the edge of that thing. So if you wanted him to stop rotating like that, I think I covered this in the last Flying AI video, but you just go to Where is he? Actually, no, not in Skywatcher. You want to go to the Flying AI folder, and in the physics move to parameters, we had a little thing here. So on the event tick, you could have the Capsule Collision. You could just have that only ever allow it to rotate its yaw and never its pitch. So let's just see if that works. It's going to be hard to get him to collide into this again, but let's worth a shot. I can't guarantee I'm going to be able to do this, but this is the end of the video, by the way, guys. If you want to stop watching, go ahead. Smack that like button, lol. Come on. He probably can't do it because... oh, here we go. He probably won't do it because his collision isn't allowing him to do it. He can't deliberately move into it because he does a box trace beforehand, so it's probably... the only reason he would have run into that was because we set his what was it, linear damping really low. So what would happen is he would have gone to move to one point and then picked another point which had a clear line of sight to, but he was still moving because his linear damping was quite low. He must have just clipped the corner. But if you do have that thing on the event tick that I just showed you, it'll constantly reset his roll and yaw every frame so that he'll never get knocked off his upright position, but he will be able to yaw around, which is good because we want him to face the direction that he's going. Okay guys, that's it for this one. Let me know if you have any questions. I hope this was helpful, and I'll see you next time. This is unrelated to the actual tutorial itself, but if you'd like to support me in making these sorts of things, I've got a link now in my description where you can make a donation if you'd like to help me make more of this stuff. Unfortunately, I don't have anything for sale just yet, but I'm planning to get to work on making some new blueprints and things like that that I might put up on like Gumroad or something, or I don't know. I'd like to start some sort of way that I could make a little bit of income from this so that I can allow myself some time to do more of it. So if these tutorials are helpful to you and you have the means to support me, like, don't feel guilty or anything like that if you can't. Like, I'm happy to do this for free in my spare time, but if you'd like to support me making more of these things, then there's a link in my description where you can make a donation from PayPal, and I would enormously appreciate that, and it would help me a ton. So thanks for watching, guys. That's it. I'll see you in the next one.